Hi friends, Namaste, welcome to our Vignan Junior College channel. Yes, in this session, I want to discuss physics class. It is physics. Now, in this session, I want to discuss motion in a straight line. Okay, listen to me. It is physics class. The chapter is motion in a straight line. In this chapter, first I want to discuss motion in a straight line, nothing but one dimensional motion, rectilinear motion, frame of reference, concept about rest and motion, concepts about path length, displacement. These I am going to discuss now. Okay. Now, what is meant by motion in a straight line? Okay, let us consider here. I am assuming a ball. Now, a ball thrown in the forward direction. A ball thrown in the forward direction on a horizontal surface. On a horizontal surface. Now, it is moving in the forward direction without change in its direction. It is moving along the same straight line without change in its direction. So, we can say that that ball is in a straight line motion. Okay, you will observe this also. Here car is moving on the horizontal surface and is moving along the straight road. Its direction does not changes. So, we also called it is in a straight line motion. We can say that it is also in straight line motion. So, study of motion of objects along the same straight line is called motion in a straight line. Study of motion of objects along a straight line is called motion in a straight line. Also, we called it as rectilinear motion. Also, we called it as rectilinear motion. Linear motion, nothing but particle is moving along the same straight line or object moving along the same straight line. That we called rectilinear motion. And also, we called this rectilinear motion as one dimensional motion. We also called it as one dimensional motion. Okay, I will describe it, one dimensional motion also. Just I will describe that one dimensional motion also. Okay, observe this. It is a room. I want to describe, before going to that one dimensional motion, I want to describe frame of reference. I want to describe a concept. It is frame of reference. Frame of reference. Simple it also. This frame of reference, nothing but it consists of a three-dimensional coordinate system. Three-dimensional coordinate system. That is, this is x-axis, y-axis. It is y-axis. I want to say it is y-axis, z-axis. Okay, it is not possible to draw that z-axis in this manner. So, I want to indicate it in this manner. This is z-axis. Not possible to draw it along this direction. Okay, here you observe these three axes. These three are mutually perpendicular to with each other. That is angle between x and y, angle between x and z, angle between y and z equal to 90 degrees. Equal to 90 degrees. These three are mutually perpendicular to with each other. Okay, here along with this coordinate system, clock, if you consider a clock, then completely this system as a frame of reference. Completely this system as frame of reference. that is a coordinate system along with clock, we called frame of reference. Now, you observe this. Now, I want to consider one corner of the room. Okay, you will observe your room also. One corner. You will assume one corner of your room. This is y axis. I want to consider it as y axis, and from the corner I want to draw a line along this direction. It is x axis, and another line, it is z axis. These three axes are perpendicular to with each other. These three are perpendicular to with each other. Once again, you observe that this is y axis, it is x axis, and it is z axis. We called this as yz plane, that is floor of your room. Assume your floor of your room. It is yz plane or xz plane, x and z, xz plane, and one wall. This is xy plane, and this wall yz plane. Floor of your room, it is xz plane, one wall is xy plane, another wall it is yz plane. Now, you consider an ant. It is moving along this direction, nothing but it is moving along x axis. We can say it is in a straight line motion, and it is moving along only one axis, If you consider one clock also at here, Now, you observe this. Now, as the time goes on increasing, what happens to position of this ant? Position of that ant changes with respect to time and with respect to this point. Here, observe this once again. This point, the point of that point which intercept these three axes, that point we called origin. That point here we called origin, or also we called it as reference point. That point we called reference point. Remember that. Okay, so I want to consider this corner as reference point. With respect to that reference point and with respect to time, what happens to position of that ant? Changes. Its position changes and is moving along x axis. So, we can say that it is in a straight line motion. I also called it as one dimensional motion, because it is moving along only one axis. Now, if you consider another ant, it is moving on the floor, it is moving along the floor. It is moving along the floor. It moves like this. That is on your floor. Now, with respect to time and also with respect to reference point, what happens to its position? Changes. And it is moving on floor, nothing but it is xz plane. So, we can say that ant is in motion in a plane, or that ant is having motion in a plane. Now, if you consider housefly, it flies from here in this manner. It flies in your room like this. That is with respect to origin and with respect to clock, that flies in space. So, that fly having three-dimensional motion. What is meant by one-dimensional motion? A particle which is moving along either x-axis or y-axis or z-axis. we can say that that particle is having one dimensional motion. If the particle moving on a plane, then we can say that that particle is having two dimensional motion. If it is moving in a space, then it is having three dimensional motion. Remember that. Okay, once again observe this. Here I am saying that it is z axis, x axis, and here it is y axis. What about these three axes? Coincides to a point. Those three are coincides to a point. This point we called reference point, or we called it as origin. That point we called origin or reference point. Now, along with this three-dimensional coordinate system, a clock is also there. Totally, this system we called frame of reference. That system we called here frame of reference. Remember that. Okay, here you observe this car moving along the straight line. Car moving along the same straight line. Observe this car moving along y axis. Here lift moving along z axis. That lift is moving along the z axis. Remember that. That means those objects are in which type of motion? They are in straight line motion, and also we can say that they are in one dimensional motion. Remember that. Now, you can observe this also once again. Here, observe this. Observe this car. That car is moving in a plane. Here you can observe this, that bomb is in xz plane. Here this bomb is in yz plane. That is, here that bomb having what type of the motion? Two-dimensional motion. Car is having what type of the motion? Two-dimensional motion. It is in xy plane in this video. Again you will observe that. Here car is moving in xy plane. Bomb is in xz plane. This bomb also in xz plane. That is, here the objects are having two-dimensional motion. Okay, next one. Observe this. Observe this video. Here in this, what about this plane? That plane is moving in aeroplane. That aeroplane is moving in a space. So that aeroplane is having three-dimensional motion. Here that aeroplane is having three-dimensional motion. Okay, next one. Now I want to discuss the concept about rest and motion. Here I want to discuss that rest and motion. Observe this. What is meant by the rest and what is meant by the motion? Here already we observed that an ant moving along the x axis, what happens to its position with respect to the corner and with respect to the time? Its position changes. That means that ant is in motion. Okay, in front of you in your room, a chair may be exist, or mobile may be exist, or book may be exist. What about their states? They are in rest position. Why? You are saying they are at rest. Because with respect to you, you are the reference one for all those things. With respect to you and with respect to the time, in the clock the time goes on increasing, but position of those objects does not changes. So, we can say that the chair at rest, mobile at rest and book at rest position. That means their positions does not changes with respect to you and with respect to the time. That is, with respect to the surroundings and with respect to time, their positions does not changes. So, you are saying it is at rest position. They are at rest position. Now, if you consider another thing here, just you observe this in this. Now, you observe this here, a boy who is on the platform, Now, I am assuming that boy as A, that boy is taken as A. The boy who is sitting on the platform, I want to consider A, and here he is B and he is C. Here he is B and here is C. Okay. Now, with respect to us, what about the state of this boy? He is at rest position. With respect to us, what about the states of these two persons? If train is moving in the forward direction, what about the states of those two persons? Just you observe this. I am saying this person B and this person I want to consider as B and this person considered as C. Now, with respect to A, listen to me carefully. With respect to A here, if train is in motion, what happens to these two persons? What about the states of those two persons? If train is moving in this direction, tell me the states of those two persons. Yes, with respect to A, B and C are in motion. Both are in motion when the train is moving along this direction. Now, another one. With respect to B, what is the state of C? With respect to B, I am asking, with respect to B, what is state of C? Does his position changes as the train is moving in the forward direction with respect to B? No. His position does not changes with respect to time and with respect to B. So, with respect to B, he is at rest position, that is C is at rest position. With respect to C or with respect to B, if you consider, with respect to B, C is at rest position. Now, you can observe these two. What is the state of C? Tell me. What is the state of C? Motion or rest? Okay, here motion and also here it is rest. That means that C exhibits two states simultaneously. Two states simultaneously. That is, to say or to describe the state of C, we need one reference point. With respect to that reference point, we described the state of C. With respect to A, C is in motion. With respect to B, C is at rest. That is, it is not possible to define rest and motion absolutely. That is, rest and motion are not absolute terms. Rest and motion are relative. Remember that. Rest and motion are relative terms. Remember that. Okay. Next one. Observe this. Already we discussed the frame of reference. What is meant by frame of reference? The coordinate system. What is meant by the coordinate system? x, y, z axis along with origin, we also called it as reference point. That coordinate system along with a clock called a frame of reference. What is meant by rest? The position of an object does not changes with respect to its surroundings and with respect to time. What is meant by motion? The position of an object changes with respect to its surroundings and time. And also we can say that rest and motion are relative. Rest and motion are not absolute, they are relative terms. Remember that. Now you tell me, what is the state of earth? Already we know that earth rotates about its own axis and also it revolves around the sun. Now you tell me, what is the state of earth? It is in motion. With respect to you, that is, you feel that earth is in motion? No, we are not feeling that thing. That is, we are saying that earth is at rest. But when you are going to moon and while you are observing the earth with respect to moon, you can say that earth is in motion. That is, with respect to moon, earth is in motion. But with respect to us, earth is at rest. That means here earth having two states simultaneously, rest and motion. It is having two states simultaneously. That is, to define rest and to define motion, we need one reference point and also time interval. So, rest and motion are not absolute, they are relative terms. Remember that. Okay. Next, I am going to explain these two, path length and displacement. Path length, I want to say it as path length. Observe this. This path length generally we called distance. Generally we called it as distance. What is meant by distance? Yes, here is there the actual length of the path travelled by a particle. What is meant by the distance? The actual length of the path travelled by a particle or travelled by an object is called distance or path length. Now, its SI unit meter. Its SI unit is meter and it is indicated by the letter small m. Here I want to discuss something. Okay, a particle moving along a straight line, its position changes, it describes certain distance which is equal to 10 meter. Someone written in this manner, 10 meter. Now, which is correct? Tell me, which is correct in these two? Is that both are correct? No, it is the correct representation, but it is wrong representation because the standard symbol for meter is small m. Don't say it is MT. And also 20 meters. If you put the plural, that is yes, it also wrong representation. 20 meter, you keep it in the same manner, 20 meter. Don't use plural after the symbol, that is 20 meter. Now, what is, how to represent 10 seconds? Listen to me, 10 seconds, 10 small s. Okay, you should not represent it in this manner. Generally, most of us represent in this manner, but this representation is wrong. 10 second, it is the standard symbol for second. Small s is the standard symbol for second. Or otherwise, you will write it in this manner, 10 seconds. 10 seconds. You must use small letter here. Now, 10 meters, small letter. 20 kilograms, small k, small g. You must use small letters for the unit, symbols of the unit. Okay, 100 gram. Is it correct? Oh, I am saying it in this manner. In these two, which is the correct one? First one is the correct one. Second one is wrong. Standard symbol for gram is small g. Generally, we represent it in this manner. Actually, it becomes 100 gram meter. If you write it in this manner, it is not 100 gram, it is 100 gram meter. Remember that. This is the standard symbol, 100 gram. Okay. Now, power of a motor. Tell me what is the unit of power? Power of motor is equal to 10 watt. Now, how to represent it? I want to write it in this manner, 10 watt or 10 capital W, 10 watt, sorry, capital W A T T. In these three, which is the correct one? Now, this and this both are correct, but it is wrong, because when you put the capital letter in front of A, that is the first letter is the capital letter, it becomes a scientist name, not it as the unit. Remember that. Okay, it is also a scientist name on the honor of what? We used it as a unit, but while describing the unit, you must use small letter, the first letter as the small letter. Now, force acts on a body, force acts on a body, F is equal to 20 Newton, force acts on a body, F is equal to 20 Newton, or it is equal to 20 Newton. You represent it in this manner. Do not use F is equal to 20 capital N E W T O N. Do not use this. These two are the correct representations. Why? Here it is a scientist name. It is not the unit. That means, in case of scientist names, you must use capital letter, first letter as the capital letter. But if you use it as the unit, that first letter should be small letter. That first letter should be a small letter. Remember that. Okay, pressure unit 20 pascals, 20 pascals. Pascals, small letter. Remember that. Okay. What is meant by the path length? Actual length of the path traversed by a particle or travelled by a particle. We called it as path length. What is its SI unit? Meter. And it is a scalar quantity. That path length is a scalar quantity. I will describe that scalar little later. What is meant by displacement? What is meant by the displacement? Tell me, what is the definition for the displacement? I think you are saying that the shortest path traversed by a particle. Is it true? Or the shortest distance travelled by a particle. But here I want to say the displacement like this. The difference between final and initial positions of a path traversed by a particle. The difference between final and initial positions of a path traversed by a particle I am not saying it is the shortest distance travelled by a particle. I will explain why I am not saying it. Just little later I will explain that also. The difference between final and initial positions of a path traversed by a particle is called displacement. Remember that. And its SI unit also meter, because it also represents length. So, its SI unit is meter, but it is a vector quantity. Here path length is a scalar and displacement is a vector quantity. Path length is a scalar and displacement is a vector quantity. Now, what is meant by scalar and what is meant by vector? I want to describe now. Already I think that you know about the scalar and vector. Once again I will explain those two things, scalar and vector. Okay, what is meant by the scalar? Scalar nothing but it is having only magnitude, a physical quantity having only magnitude, need not be required the direction, need not be required to indicate the direction. Remember that. A physical quantity having only magnitude, we called it as scalar quantity. Now, what is meant by vector? Tell me. What is meant by the vector? Yes, a physical quantity having both magnitude and direction. You are saying like that. Okay, it is the correct definition. No problem. What is meant by the vector? It is having both magnitude, direction. Both magnitude and direction. Both magnitude and direction. Having both magnitude and direction. But observe this. If you consider an electric current, tell me, it is having both magnitude and direction or not? You are very familiar in your 10th standard. Electric current, yes, it is having both magnitude and direction, but it is not a vector quantity. Yes, it is not a vector quantity. Even though it is having both magnitude and direction, it is not vector. Speed of light, it is having rectilinear motion. It is having both magnitude and direction. Speed of light, both magnitude and direction, but it also not a vector quantity, it also a scalar. Remember that. Even electric current and speed of light are having both magnitude and direction, they are not vectors, they are scalars. Now, what is the perfect definition for the vector? Tell me, what is the perfect definition for the vector? It is not the perfect definition. Both magnitude and direction, okay, it is having both magnitude and direction, but actual definition for the vector is a physical quantity which is having both magnitude and direction and also obey laws of vector addition, LAWS, laws of vector addition. What is the laws of vector addition? We will discuss it in the next chapter. It is in motion in a plane. Until you remember that vector nothing but it is having both magnitude and direction, also obeys laws of vector addition. Laws of vector addition. Remember that. Now you tell me what is meant by the scalar? A physical quantity which is having only magnitude. What is meant by the vector? A physical quantity which is having both magnitude, direction and also obeys laws of vector addition. Okay, just observe this board. I will come back within 2 minutes. ఏనంటో టైం అవుట్ చెప్తున్నావా? Okay, I want to describe the applications about both path length and displacement. To do those applications, these definitions are very important. By using those definitions, I will explain the applications on both path length and displacement. Listen to me. Here, a car moving along the straight line. That means that car is in one dimensional motion. That car is in one dimensional motion. That is motion in a straight line or rectilinear motion. Okay, let us consider A is the reference position for our discussion. Nothing but 0. B. I want to consider position of B 100 meter. 0 meter and here it is 100 meter. Position of B is 100 meter. Now, a car travel from the position A to position B as the time goes on increasing. That means with respect to A, that car is in motion because its position changes. So it is in motion. Now in this, what is the distance travelled by the car or path length travelled by the car? Path length. Here onwards I want to take it as path length instead of distance, or you will take distance, no problem. What is the path length travelled by the car? What is meant by path length? Actual length of path travelled by the car. Actual length, it is equal to 100 meter. Now what is meant by displacement? Tell me the definition for the displacement here. Yes, it is final position minus initial position. Okay, you choose it as x axis. I want to consider it is x1 and it is x2. x1 is equal to 0, x2 is equal to 100. Now displacement means final position minus initial position, x2 minus x1, that is equal to 100 minus 0, which is equal to 100 meter. 100 meter. Path length 100 meters, displacement also 100 meters here. That means during this, okay, in this example, these two are same, that is path length is equal to displacement. That is, a particle moving along the same straight line without change in its direction, we can say that path length is equal to displacement. Remember that a particle moving along the same straight line, path length is equal to displacement. Remember that. Next one, observe this. I want to consider here, okay, because of this diagram I want to draw another diagram here. There is a small mistake in this diagram. Now I want to draw another diagram here. Let us consider a particle moving along the same straight line. Okay, it is reference point 0 meter. I want to consider it as x axis 0 meter, and it is taken as A, it is taken as B, and this point is taken as C. A position is 50 meter, B position 100 meter, C position minus 50 meter, position of C minus 50, and it is O, it is 0 meter because it is the reference point. Now I want to consider a person who is moving from O to A, O to A, O to A. He is moving along this line. First he travels to this point A, that is for O to A. While he travels from O to A, in this situation, tell me the distance travelled by the particle or distance travelled by the person. Also we called it as path length. Instead of distance you can also use path length. What is distance or path length? What is meant by path length? Actual length of the path travelled by the particle. Here what is actual length of the path travelled by the particle? That is person. Yes, actual length 50 meters. Now you tell me displacement covered by him. Now you tell me displacement covered by him. Displacement means final position minus initial position for his journey up to here. It is final position and it is initial position. So final position minus initial position, that is equal to 50 meters. Okay. Now that person does not stop there. He is moving in the forward direction and he reached to this point B. Now for this journey, that is O to B, O to B, for this journey, tell me the path length travelled by the person or distance travelled by the person. Distance nothing but actual length of the path travelled by the person. Now you tell me what is the actual length of the path travelled by the person. Yes, it is 100 meters. Very good. It is 100 meters. Now what is displacement covered by him? Displacement covered by him. Tell me displacement covered by him. Displacement nothing but, yes, it is final position minus initial position. Now for this journey, final position is 100 meter, initial position is 0 meter. So it becomes 100 meter minus 0 meter, that is equal to 100 meter. Now he does not stop at here. He wants to come back to this point O. He wants to come back to the point O along the same straight line, but for my convenience I want to use another line here. But for my convenience I want to use another line. I want to use this line, but actually he is moving along the same straight line, same path, but for my convenience I want to use another line. Now O to B and from B to O, B to O, he travels that manner, O to B and B to O. For that journey, tell me distance covered by that person or path length covered by the person. Distance covered by the person. What is meant by distance? Actual length of the path travelled by the particle. What is this length? 100. What about this length? It also 100. Total length, yes, it is 200 meters. Total length of the path travelled by the particle. It is 100 and this also 100. Total length becomes 200 meter. Now you tell me displacement covered by the particle. Here you tell me the displacement covered by the particle. That means person. Displacement means, yes, it is final position minus initial position. It is here his initial position and he again reached to that position, that is his final position also coincides with his initial position. Is it true? Final position coincides with the initial position. So, displacement becomes 0 meter. Here displacement becomes 0 meter. Now, again he wants to travel further in the backward direction. He wants to travel further in the backward direction. He does not stop there. Again he is moving in the forward direction and he reached to the point C finally. Finally he reached to the point C. That means he starts at this point, he is moving from this point to B and again he come back to point O, but he does not stop there and he reached to that point C. For this complete journey, I want to describe it here. O to B and from B to C, B to C, O to B and B to C. For that complete journey, tell me the distance or path length. What is distance or what is meant by the path length? What is meant by distance? Actual length of the path traversed by a particle. Actual length of the path traversed by a particle. Now, O to B, path length 100 meters. B to O, path length 100 meters. O to C, length of the path 50 meters. Do not say it is minus 50 meters, because actual length of the path travelled by the particle. Just you measure this total length, just you measure the total length. 100 plus 100 plus 50, totally it becomes 250 meter. Do you understand that? Total length of the path travelled by the particle. That means just you measure total length of the path. How much? 100. 100 plus 50. Totally it becomes 250 meters. Now you tell me displacement covered by the particle. What is the displacement covered by the particle? Displacement means, Yes, it is final position minus initial position. For his journey, what is the final position? C is the final position. Yes, it is the initial position. He starts at here and he is moving in this manner. That means it is initial position and it is final position. So, displacement nothing but final position minus initial position. It becomes minus 50 meters. Final position minus initial position indicates displacement. Remember that. Now, you observe all these things. When the body or a person or a particle moving along the same straight line, we can say that distance is equal to displacement. Only in that condition, distance is equal to displacement. When the particle is moving along the same straight line, then only distance is equal to displacement. Now, here you will observe this one 100 meters, 100 meters, because particle is moving along the same straight line. Here in this situation, distance is there, but displacement is equal to 0 meter. Now, in this situation, distance is there, but displacement minus 50 meter. Now, in these three cases, distance always positive. It appears that distance always positive, nothing but path length always positive. What about displacement? It may be positive, it may be negative, it may be equal to 0, but path length is always positive, it is not equal to 0. Remember that point. And next one, another application. Now, you observe this application. Here, a particle travels from A to B, in this path, along this path. It travels along this path. That is, you assume there are the two towns A, B. Now, you can assume it is Hyderabad. Oh, sorry, not required that. Here there are the two towns. You can assume there are two towns there. A and B. In between these two towns, a valley is there. A valley, a deep valley is there. That means there is no road along this direction, no road along this direction. Remember that. There are the two paths, that is, two roads are there. One road is constructed in this manner, another road is constructed like this. There are the two paths, that is, two roads are there. Now, this road length is equal to 200 meters, this path length is 350 meters. First path, second path. Here its path length is 200 meters, its path length is 350 meters. There is no path in between A and B along this manner. Remember that thing. A deep valley exists in between A and B. Now, you tell me, with respect to path 1, in case of path 1, what is the distance travelled by the particle or distance travelled by the bus? Distance nothing but, or path length nothing but actual length of the path travelled by the particle. Now, actual length is equal to 200 meters. Actual length is equal to 200 meters. Now, just you observe this. One minute, I am sorry. Okay. For the path length 1, distance is equal to how much? 200 meters. Now, if you consider next one here, that is, if you consider path 2, in case of path 2, tell me what is the distance travelled by the particle. In case of path 2, tell me the distance travelled by the particle. Actual length of the path travelled by the particle, it is equal to 350 meters. Yes, it is equal to 350 meters. Now, is there any road in between A and B along this line? No, just I draw a line, but there is no road here. Now, for this path 1, how much the distance? 200 meters. For the path 2, how much the distance? 350 meters. Now, you tell me what is the displacement of that bus or that particle in case of path 1 and in case of path 2. Already we know that here displacement nothing but final position minus initial position. It is final position minus initial position. And also you know another definition, what it is? The shortest path travelled by the particle. The shortest path travelled by the particle. Shortest path travelled by the particle, but it is wrong, because here which is the shortest path? It is shortest path. It is the shortest path. Is that shortest path is the displacement? Is that shortest path is the displacement here? Okay. Shortest path travelled by the particle, shortest path travelled by the particle is the displacement? No, displacement nothing but it is final position minus initial position, because here you observe this, it is, you are saying that it is the shortest path, you are saying that it is the shortest path. But displacement for this path is final position minus initial position. What is final position? 50 meters. Initial position 0 meter. Therefore, final position minus initial position is called the displacement. Remember that, not it is the shortest path travelled by the particle. Now, for these two it is the shortest path, but 200 meters is the displacement? No, 50 meters is the displacement. That is why I am saying that displacement means final position minus initial position. Displacement nothing but final position minus initial position. You remember that. Do not say it is the shortest distance travelled by the particle, shortest path travelled by the particle. Okay? Thank you. Please subscribe our channel, that is Vignan Junior College. Okay, we will meet again tomorrow. Thank you. ఎన్ని మినిట్స్ ఎక్కువ వచ్చింది? కరెక్ట్గా అయిపోయింది. ఇంకా ఉంది. ఇంకొక స్లైడ్ ఉన్నట్టుంది, ఇంకా 2 స్లైడ్లు ఉన్నాయి.
తర్వాయి భాగం రేపు.
అదే 4 minutes అని చూపిస్తారా? అందుకే
మళ్ళీ కంక్లూడ్ చేస్తారో లేదో అన్నట్టు.
ఇంకా కంక్లూజన్ ఏముంది, అక్కడైతే అక్కడ అయిపోతున్నాను. తెలిసింది అసలు ఏం లేదు, అసలు ఎక్కడ కంక్లూడ్ చేసేది లేదు.